Dear students, very good morning. This is Professor Subramanya Bhagavat, your computer science coordinator. Welcome back to discrete mathematical structure. There I was explaining you about graphs. Fifth model we were studying. First model and fifth model we are completing in online. Yes, all right. Now, complement of a graph. What is a complement of a graph? Let G be a simple graph with some vertices as that of G dash, what I call with an example through, I will tell you, so that you understand the concept very easily. Observe this, okay, wait. Observe this graph, okay, this is, I call it as a complete graph. If I remove B, D and CD from this okay graph, what is the complement of that graph? I want to know. This is a G, this is a G1. I want to find out that complement of a graph, that is a G minus G1. What is G? This is G. Okay. What is G1? Okay. B, C, D. This is G1. This is G1. Am I right? If I remove G1 from this graph, remaining is this. This is complement of this one. So this is called complement. So we understood. Please try to concentrate on it. We understood if from complete graph, if I remove a part, okay, then what is remaining is complement of that part. This is a complement of this part. So we understood complement. Okay. Next one is a rooted tree. What is a rooted tree? What is a tree? Tree is clear to you. Tree is nothing but, yeah, graph which contains, okay, just recall the tree definition. Yeah, tree definition, connected graph with no, what is with no what? Try to analyze that. Connected graph with no cycles. So a graph which doesn't contain parallel edges, loops and connected graph, I call it as a tree. What is a rooted tree? Let D be a directed graph, G be underlining graph. We say that D is a directed tree, whether G is a tree. Directed tree is called directed graph whose underlying graph is tree. Directed tree is called a rooted tree. First one, T contains a unique vertex called root. Unique vertex called root, whose in degree is equal to 0. Whose in degree is equal to 0. Second one, the in degree of all other vertices equal to 1. In degree of all other vertices equal to 1. That is called a rooted tree. If you observe this, okay, first rooted tree definition is clear to you. That definition clearly says first one vertex, unique vertex called root, whose in degree must be equal to 0. And okay, in degree of all other vertices must be 1. If you observe this bit, what was second? A directed tree is said to be rooted tree. It contains unique vertex whose in degree is 0. If you observe this first graph, in degree is 0. So this is a root. And other vertex, okay, in degree is 1, minimum 1 because it should be connected. In degree of other vertex is 1. This is unique vertex. This is called root. This is called root, V0. Whose vertex whose out degree is 0 is called leaf. Last elements in a tree. Okay, wait. If you observe this is a root. Why? These are all the leaves. Okay, root means in degree is 0. No other edges, okay, insert to that vertex. While leaf means out degree is 0. V3 is leaf, V4 is a leaf, V7 is a leaf, V8 is leaf, V6 is leaf. Out degree is 0. In degree is 0 called loop, root. out degree is 0 called leaf. Out degree is 0 called leaf. If you observe the second graph, this is not a second graph is not a this one what I call rooted tree, because second graph, this is not a root. In degrees 2, in degrees 0, I am not getting anywhere. So it is not a this thing. So observe the arrow directions. So you understand. So first one is a this one rooted tree. First is a root, V0 is a root, in degree is 0, where leaves V3, V4 last, that's leaves out degree is 0. Next is, yeah, observe this with examples. We note the following points with reference to vertex V0 is, if you observe vertex V0, carefully observe that. Yes, take us 2 second time and observe that. What are the points you are seeing there in that example? Yeah, observe that very clearly. First thing is V0 is the root. Will you agree my point? Because, yeah, V0 is here, arrow direction he has not given. Try to understand that. Okay. Yeah. We take note the following points with reference to rooted tree. Vertex V0 is the root T and it's to the level 0. This because, wait. Here direction not mentioned. So I call it as it's a level 0. This is a level 1. And this all these things level 2. This is a level 3. Okay. What is available in the level 0? V0 is the root. I call it as V0 is the root. And level 1, V1 and V2, level 1. And V3, V4, V5, V6 are, okay, sorry, wait. Yeah, V3, V4, V5, V6 are level 2 and level 3, V7 and V8. Now, some other points also just try to carefully watch. So the concept will be very, very clear to you. First one, vertex V2 is the ancestor of the vertex. This vertex V2, if you take this vertex V2, is the ancestor of the vertices V5, V5, V7, V8 and V6. Am I correct? Yeah. Wait. Try to understand the concept very clearly. Vertex V2 is the ancestor of the vertex. Please try to observe carefully. Vertex V2 is the ancestor of the vertices V5 and V7, V8. Okay. And yeah. Now, next one, okay, distance of, try to understand this. Vertex V1 is parent of V3 and V4. V1 is parent of V3 and V4. And V3, V4 are children of V1. V3, V4 are children of V1. Next one, V1, V5, V6. V1, yeah. Try to understand that very clearly. Okay. Yeah. If you observe that, sorry, V5, V6. This V5, V6. These are siblings. And V3, V4, V6, V7, and V8 are leaves. Last, okay, what is the leaves? We understood that things. Next, yeah. Next, concentrate about binary tree. What is binary tree? Rooted tree is called binary tree. Every vertex of T is out degree is lesser than or equal to 2. Out degree is lesser than or equal to 2. Not more than 2. Remember that. Okay. If you observe that rooted tree is called binary tree, every vertex of T is out degree is lesser than or equal to 2. That is, a vertex has almost two children. Almost two children. Complete binary tree means every vertex of T has exactly out degree equal to 2. Then the tree is said to be complete binary tree. Complete binary tree, because every vertex of T has exactly out degree is equal to 2. Let T be complete binary tree of height h if all the levels of T are level h or h minus level h, that's called full binary tree. That I will tell you. So the concept will be very clear to you. Observe that this is a binary tree, no doubt at all. Because what is the degree of this? Wait. Yeah, what is the degree of this vertex is 2. What is the degree of this vertex is 2. Degree of this vertex 2. Wait. Degree of this vertex is 1. Degree of vertex is 0. Here degree leaves 0. Others this one is 1. Every vertex's degree less than or equal to 2, so it is binary tree. Or if you observe the second one, complete binary tree, here every vertex's degree is equal to 2. No one is saying 1. This inner nodes, not leaves. This is 2, 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 this is except leaves. Inner nodes are all having equal degree 2, then it's called complete binary tree. Full binary tree means, for example, each level, if you observe this, you see here very carefully. Up to this level, this is a binary, not full. This third level, only this one, has. So others leaves already done. Complete binary tree, full binary tree means full level. For example, this is a level 0, level 1, level 2, level 3. Except all means, in other words, H level means all leaves should be in H level. Every vertex should have 2 degrees. That's all. Next, balanced tree. Rooted tree height H is said to be balanced tree if every leaf level H or H minus 1. Every leaf, every what I call, every leaf comes in the category level H or H minus 1. It is known as balanced tree. It is known as balanced tree. If you observe this, T1, T2 are balanced trees because every leaf, if you observe the leaf, this leaf, wait. What is the level? There is a, observe this very clearly. It's 0, 0, 1, 2, 3. Level is 3, correct? 1, 2, 3. Every leaf should be available, either 3 or second level. Observe this is the third level, this is second level. H minus 1. Every leaf is available in that height H or H minus 1. So it is, first one is balanced tree. Where if you observe that second one, this is a level 0, this is a level 1, level 2 and level 3. Every leaf is available third level or second level. No doubt this is a balanced tree. Where if you observe that last one, this is a level 0, this is a level 1, level 2 and level 3. All leaves are available at level 3 and level 2. No, this is available in level 1, H minus 2. So it is not a balanced tree. Next, find out which of the following is rooted tree. Take us 2 seconds time. Is not visible? Wait. Find out which of the following is a rooted tree and not rooted tree. First one, please carefully observe. First one is a rooted tree because it has a root D 0. First one is a rooted tree because this is one unique vertex having in degrees 0 or level 0. But here in level 0, 2 vertex are available. So second one, this one I can say not consider root. This one also can now consider root. So this is not rooted tree. Second one is not rooted tree. Next one, find the rooted tree shown below the levels of AHFM. For rooted tree shown below, find the levels of AHFM. What is the level of A? observe this carefully. Wait. What is the level of E? Just simple. Okay, what we call this root should be always at level 0. Second, level 1. Then, yeah, this is level 2 and this level 3. So, root should be always at the level 0. What is the level of A? Level of A is available in 1. So, level of A is 1. Level of H is available at 3. Level of H is 3. Level of F is 2. And level of M is, okay. M is, okay, after this, again M is, wait. Another way is also there. I will find out. I'll tell you. Level of M I want to find out. From root, how many distances available? You just find out. 1, 2, 3, 4. Level of M is 4. Because 4 edges required to reach that node. Level of A, another way I will find out. Level of A from root, 1 edge is required. So level is 1. Level of H, okay, 1, 2, 3. 3 edges required, 3. Other way, 1, 2, 3. Correct. Level of F, level of F is, okay, 1. Yeah. Try to observe this very clearly, okay. Like this way, you can find out it very easily. So, we have understood, yeah, wait. So we have understood the concept. Level of F I was telling. Yeah, 1, 2 edges required. So level of F is 2. Where level of M, 1, 2, sorry. Level of M, 1, 2, 3, 4. Am I right? Like the level of M is 4. Like that way you can find out how many edges required to reach that node from that root. That's called level. Next question, yeah, what it says in three shown vertices which are leaves. Find out vertices which are leaves. K, P, Q, S, T, and F. These are all the leaves. Okay, last available nodes I call it as leaves. Next one, yeah, which is the root? What he says? Which is the root? Anybody can identify which is the, yeah, which is the root? Can you identify? Yes, this is the root. A is the root. Then next question. What is the next question? Third question. Parents of G. Parents of G. Wait. Parent of G. Okay, where G is there, you find out. Okay. G is available. Okay. Here. Parent is no doubt D. Parent is D. Next, because this is the parent of G. Okay, next. Next question he asks descendants of C. Descendants of C. What are the descendants of C? Descendants of C, E, J, Q, S, T. These are all the descendants of C. Next, siblings of S. Siblings of S. Siblings of S are Q and T. Q and T are siblings of S. Q and T are siblings of S. Next one, yeah, wait. Next question is vertices having the level number 4. Vertices are having level number 4. This is a level 0. This is level 1. Am I correct? This is a level 2. And this is level 3. Am I correct? This including this level 3. Level 4, this one. KPQST is level 4. Or 4 nodes required to reach that. I told K. 1, 2, 3, 4 edges required to reach from root. P, 4 edges required. 1, 2, 3, 4. 4 edges required. Okay. Next, which of the following is a binary tree? Complete binary tree and or tree. First one, if you observe it. Which of the following is a binary tree? It is not a binary tree, first one, because this degree is 3. Binary tree definition says any root's degree, any node degree must be less than or equal to 2. Second point, second point, it is a binary tree because every root's degree is equal or less than equal to. But observe that not complete because here if you add one more this is a complete binary tree. Complete binary tree because every vertex has degree 2. Okay, next.